For decades, engineers believed moving a bus engine to the back would solve almost every problem. Quieter rides, more passenger space, and easier boarding. Instead, it created a nightmare of overheating, maintenance headaches, and costly redesigns that threatened the future of modern buses. So why didn't engineers abandon the idea? The answer transformed public transportation forever. To understand why engineers took such a huge risk, we first need to look at how buses were originally built. Early city buses weren't designed from scratch. They were essentially trucks modified to carry passengers instead of cargo. Since truck engines sat at the front, buses inherited the same layout. It was simple, reliable, inexpensive to build, and easy for mechanics to service. But as cities expanded, buses had to carry far more passengers and operate almost non-stop. That's when the old design began showing its weaknesses. The large diesel engine occupied valuable space behind the driver, forcing the floor upward and creating steps inside the cabin. Boarding became slower and more difficult, especially for elderly passengers, parents with strollers, and people using wheelchairs. The engine also generated constant noise and vibration, leaving drivers to spend entire shifts beside a running diesel engine, while conversations near the front became more difficult. Weight created another challenge. A heavy engine over the front axle placed additional stress on suspension and braking components, while upsetting the vehicle's balance. None of these issues made buses unusable, but together, they convinced engineers there had to be a better solution. The answer seemed obvious. Move the engine to the rear. At first glance, it looked like the perfect engineering breakthrough. Relocating the engine immediately transformed the passenger experience. Without the bulky engine compartment at the front, designers could lower the floor, making boarding faster while greatly improving accessibility for wheelchairs and strollers. The front of the bus also became much quieter. Moving the engine away from the driver's compartment reduced noise and vibration, creating a more comfortable environment for both drivers and passengers. The extra interior space even allowed buses to carry more people without increasing their overall size. Weight distribution improved as well. Positioning the engine at the rear, while passengers were spread throughout the cabin, created a more balanced vehicle for stop-and-go city driving. On paper, the rear engine layout solved almost every major complaint. But engineering is never that simple. Moving the engine meant redesigning almost every connected system. The transmission layout changed, cooling systems had to be completely re-engineered, airflow through the engine compartment disappeared, and maintenance became far more complicated. Think of it like moving the kitchen to the opposite side of a house. You aren't just relocating the stove. You also have to redesign the plumbing, wiring, ventilation, and gas lines. Exactly the same thing happened when engineers moved the bus engine, and one challenge quickly threatened the entire idea: keeping the engine cool. Moving the engine to the rear made buses quieter, more spacious, and easier to board. But it also created one of the biggest cooling challenges engineers had ever faced. For decades, front-mounted engines relied on fresh air flowing naturally through the front grille and radiator as the bus moved forward. That airflow disappeared the moment the engine moved to the rear. Instead, the engine sat inside a compact compartment where cooling depended entirely on carefully designed vents, radiators, ducts, and powerful fans. The problem became even worse in city traffic. Unlike highway vehicles, buses spend much of their day stopping, waiting at intersections, and crawling through congestion. At those low speeds, very little natural airflow reaches the rear, forcing the cooling system to do almost all the work. Engineers soon realized that simply relocating the radiator wasn't enough. They had to redesign how air entered the engine compartment, flowed across the radiator, and escaped afterward. Some manufacturers experimented with roof-mounted cooling systems, while others relied on large side vents and powerful cooling fans. What looked like a simple decision, moving the engine a few meters backward, had become one of the most difficult airflow problems in public transportation. And cooling wasn't the final obstacle. The next challenge appeared every time mechanics needed to repair the bus. Think about opening the hood of a car. Almost everything you need is right there. Mechanics can easily inspect belts, hoses, filters, and other major components. Now imagine moving that entire engine into a compact compartment at the very back of the bus. Suddenly, routine maintenance becomes far more complicated. Early rear-engine buses forced engineers to rethink almost every maintenance procedure. Components had to be rearranged, cooling equipment squeezed into tighter spaces, and mechanics needed new ways to reach parts that were once easily accessible. Even simple repairs often took longer because the entire powertrain was packaged differently. The transmission created another challenge. Front-engine buses had decades of proven engineering behind them, but moving the engine to the rear completely changed how the engine, transmission, and driveline worked together. Engineers had to redesign the drivetrain to deliver smooth, reliable power under constant stop-and-go city driving. Early transit agencies experienced reliability issues as manufacturers refined these new systems. Cooling layouts improved, transmission components became stronger, and maintenance procedures became more efficient. None of these problems meant the rear-engine concept had failed. They simply proved that solving one engineering problem often creates several new ones. But manufacturers refused to go back. As manufacturers solved the cooling and maintenance challenges, something remarkable happened. Passengers had already embraced the new buses. The lower floor made boarding faster and safer. Drivers enjoyed a quieter workspace, while transit agencies realized they could carry more passengers without increasing the vehicle's length. Most importantly, the rear-engine layout allowed engineers to design buses around passengers instead of machinery. Space once occupied by the front engine became usable for wider doors, simpler wheelchair ramps, and better passenger movement throughout the cabin. Those few seconds saved at every stop added up across hundreds of daily trips, improving efficiency across entire transit systems. The redesign wasn't simply about moving an engine. It completely changed how cities moved millions of people. And that's why manufacturers continued improving the concept instead of abandoning it. But just as engineers perfected the rear-engine bus, a completely different technology arrived. Today, public transportation is entering another major transformation. This time, engineers aren't moving the engine, they're removing it. Electric buses replace large diesel engines and complex transmissions with compact electric motors mounted near the drive axle, while battery packs are distributed throughout the vehicle to improve balance and stability. Many of the engineering compromises that shaped diesel buses for decades suddenly disappear. There's no massive engine compartment generating constant heat, no long driveline running through the vehicle, and far fewer moving parts requiring regular maintenance. Instead of asking, should the engine be at the front or the back? Engineers now ask a different question. Where should we place the batteries? It's a reminder that engineering never reaches a final answer. The front-engine bus solved the challenges of early manufacturing. The rear-engine bus transformed passenger comfort, accessibility, and vehicle balance. Now electric buses are redefining public transportation once again, proving that every generation builds on the lessons of the one before it. The next time you board a city bus, remember that its simple layout is the result of decades of engineering challenges and innovation. If you enjoyed uncovering this hidden story, tell us what everyday machine we should explore next, and don't forget to subscribe for more engineering secrets.